Hi guys, just wanted to welcome everyone here to the webinar today. We had a really great response from everyone at the Smart Energy Conference a couple of weeks ago, and we're really excited to bring you this training today. So I think we've got somewhere around 120 installers registered to attend today. So look, I think there's been a lot more awareness around the fact that there's just a better way to install solar on metal rooftops. And that's really something that S-5 is really the global leader in, with, endorsements across the roofing industry. And, I think it's just a much smarter, faster, better way to install solar on metal rooftops. So I'll now pass over to Dustin to take you through the first module for today. Thanks, everyone.
Hello, everyone. Thank you for joining. You've got me and Bernie and Mark Guys. Bernie and I are going to kind of go back and forth in this presentation. Bernie's there in Hamilton and has plenty of experience using S-5 products, and can kind of walk through the do's and the don'ts, where I can give more of who we are, what we do, and why we do it. So let's dive in. I'm going to go ahead and share my screen. And when I do this, I'm not going to see anybody anymore, so somebody yell at me if it's not looking right. What the title is today is the Railless Revolution. We're going to go through kind of the ins and outs of metal roofing and why it is the perfect platform for solar PV. And being able to do so without a rail. Bobby, as you heard earlier, went through our copyright information. And starting out again, Dustin Haddock, I'm the Vice President of Research and Development. I'm here with Bernie Dombrowski. He's training consultant with the APAC region. And again, with your questions, please keep them in the Q&A, not the chat. We'll be trying to answer those. Mark's here with us. We'll be trying to answer those as we go. However, we do have a break during the presentation after we talk about earthing and whatnot, that we trust that you'll funnel us with questions that we can answer at that moment. Bernie, I'm going to pick on you here with this slide. You have a lot of experience with rails, using rails, selling rails, and curious if you can go over this one here for us.
Yeah, absolutely. Thanks, Dustin. G'day, everybody. Welcome along. It's good to see you all again. I know we saw a lot of you at the show last week, so we appreciate your time. Look, one of the things I looked at very heavily in the early days with trying to find a solution to some of the issues that we're finding on roofs is just what are rails doing for me at the rooftop, and where can I get better bang for my dollars? And it really started to drill down into the fact that a 4.2 rail holds onto 4 modules in the standard terms, and now we have the 4.4 rail for the larger modules at 1048. But in real terms, it really works out that it's simply only 7% and a bit come in contact with a module, and 5% of that rail is only contacted to the surface, depending on the wind zone and how many fixing spacings you have in that system. So in total, around about 12 to 13% of that wonderful rail system we have up there is engaged with the modules in the roof, which leaves 87% just solely being used for railing and for the distribution of earth around the array. So that is, a pretty expensive way to move earth and cables around the array. If a rail costs $20, then $1.42 of it is in contact with the module and $1 in contact with the roof, leaving the $17 odd of lovely aluminium moving cables around and earth, and of course the embodied energy to create rails and what's not. It's an expensive thing, so I won't call it scrap, but it is unnecessary weight. So the great thing about the PV kit, if you've never seen it, and which you're going to experience today, and is that it comes into 100% contact with the module on the roof. There's no waste. It's significantly lighter than any system out there, and the speed, which you're going to learn as we go through this, is incredible. And I think the magic is that, as all installers know, who've spent a bit of time on the roof doing solar, is that our Achilles heel is that anything we do on the roof is predicated around where the fixing lines are and what we can attach to those. So enjoy the next hour of, for those of you who've never seen this before, it's a wonderful, wonderful system. So enjoy. Dustin, back to you, my friend.
So one of the beauties of the metal roof is metal roof, whether it's exposed fastener or standing seam, has rails already built into them. And you can see that there, every rib there, can be considered a rail. They're predetermined spacing, whether it's, sorry, I'm going to speak in imperial, but whether it's 9 inches or 12 inches or whatever the seam spacing may be, you've got a rail already built within that roof. We brought this photo to attention because the climate in the PV industry, for sure, especially in the APAC region, is going more towards mounting landscape. And you'll notice, I don't know if you can see my cursor here, but they're running rails on top of essentially the rails that have already existing on the roof to install the system. They could have saved a lot of time and energy to delete the rails and mount the modules directly to the roof. And we're going to go through how that's done. Starting out a little bit, S-5, we've been around for quite a while, and our history, our roots is metal roofing. And we've come up with ways to fix things to metal roofs. Our philosophy is a metal roof, in our opinion, is the greatest roof that exists. And the only downside that it has is it's not a good way to attach things with it without being invasive to the roof. So our mission is to come up with products that aren't invasive to the roof, that allow you to fix things to the roof, that'll survive some of the harshest climates within the world. And we've done a pretty good job of getting that accomplished. Some of our big box brands, big names, big projects, things that we've done, you might recognize this building. This is Apple World Headquarters. In 2017, this was constructed, and at that time, it was the largest metal roof mounted PV array. Everything on this roof was done rail free, direct attach with the PV kit, fixing the modules directly to the roof. So what you're seeing right now in your foreground is 7.4 megawatts fixed railless, 6 miles of service walkways. The clamps themselves were used to attach the service walkways, 2+ miles of edge coping, and the largest fall protection system in the world. Our history has got over 2 gigawatts of solar installed on metal roofs. Big box brands, they trust us because of our proven track record. We do what we say we're going to do, and moreover, our technical know-how. Homeowners trust us because we're reputable and affordable. Playing in the industry, we get to know those that are also in the industry, maybe at a different level. What you're seeing here is Ange Brazillo, who was on the team that helped design the coating that's most popular on all metal roofs, which is zinc aluminum. We call it Galvalume. And you'll see Ange gives a shout out right there that says S-5 is the greatest thing to happen to metal roofing since Galvalume. Reason being is zinc aluminum made metal roofs last longer. S-5 preserves the integrity of that roof and lets it be more user friendly. Here you're looking at one of the early designs that we had, one of the early direct attached systems that we did, which was a vineyard, Rodney Strong, if you're into wine, which was constructed in 2005. FedEx, Google, and Costco. This is a 2.43 megawatt system, all done rail free. In fact, the only penetrations on this roof were done because at that day and age, they had to run a lot of wiring for grounding. And at some point where all the wires came together, it would have overloaded the roof system itself, so they had to cut into the roof and reinforce the framing strictly for the wiring. Since then, we've come up with ways that make that a lot easier. This is the highest elevation solar array in the world. This is Mauna Kea, Hawaii, 4,200 meters tall. And notice it's all rail free. If you were to try to do this system with a rail, you see we're attaching these modules 1, 2, 3, 4, 5 times. It would have taken 5 rails underneath every module to get the same wind speeds and the same design circumstances. This project, ironically, just before COVID hit, I was out in Auckland with Bernie and Lightforce, where we installed about 100 kW. When I say we, Bernie and I were there just for a couple kW, going through some of the learning curves. Notice that there's about 100 kW in that van of product to install. If you were to do that with rails, there's no way you would have got it right there in that van. A shout out from Lightforce is, as you can read right here, they were installing 1 panel every 80 to 120 seconds, which meant they can install rows of 17 in 21 minutes, which was a dramatic increase in efficiencies in terms of the labor and putting the system up. Delivered around 20% of the cost savings on the framing and 85% weight reduction. The team that installed it said that they were blown away and they never want to install rails again. This was a first-time use from Lightforce, and they were ecstatic about the product. Real quick, who is S-5? We've been doing this for a long time, putting things on metal roofs. That's our business. That's what we've done. That's what we become known for. We're the #1 attachment solution source, and we've got a project portfolio of over 2 million roofs worldwide. We're not just in the US. We have a great presence internationally, and we're working to build that presence in your part of the world. Ways that we've become so recognized within the industry is not only do we work with installers, integrators, people that have a metal roof, but we work with the people who make the metal roof. And we have recommendations, endorsements, as well as some of these metal roofing manufacturers also carry our products just because it makes their product easier to use. Before we ever do anything, we get with the roofing manufacturer, make sure that they're comfortable with our products. What we intend to do, we give them the testing, the engineering, everything, so that we get their endorsement of our product being used on their roof. And we have that from every major metal roofing manufacturer that you can imagine globally. I talked a little bit a minute ago about testing. Some of the reasons that we have that endorsement is because we don't just test a roof that looks like somebody else's roof and says that, yeah, this is good. We have over 3,000 individual tests. When I say individual tests, it means that we put our product on their specific roof, on that specific roofing material thickness, and we run a series of pull tests quantifying the loads of which our product is going to be able to withstand on top of their roof. Which is why we get the endorsements from like MBCI. MBCI is the largest metal panel producer in the world. And you see there, after 40 years in business at MBCI, we know the difference between impersonators and the real deal. We work hard to maintain those relationships. In doing so, it's not a one plant fits all. And so we have a product portfolio that is essentially a family with over 50 patents and a 30-year track record. You know, we solved a permanent solution to a 1,000-year-old problem. And that's why you see all the different SKUs. You know, in your part of the world, we became known a little bit as, well, if we don't have a product that'll fit it, S-5 does. We specifically design our products specifically for that roof. To make sure that it is a hand in glove fit. It's not it's not a one piece fits all, which is why you see all the different products that we have here. I want to go briefly over Corey. We created the S-5 core bracket 500 TPV. This was specific for the Australian market and specific for the corrugated roofs that you're seeing there. The 500 TPV is designed so that it gets you the right height that you can get your hands up underneath the modules for your wire clips. It has 4 points of attachment that goes into the sheeting, and it basically makes the roof your canvas. You're no longer tied to finding structure. You can go directly into the sheet and install on that roof rail free. When we were at the show last week, one of the big questions we got was, okay, how does this go in place? I'm sure you're used to thinking about a rail, and you've got to do your layout and specifically lay out the rails, and then do your wiring, and then put the modules on top of the rails, etc. And so wrapping your brain around not having the rails, well, what do we do? The system is designed to be kind of on the fly. So all of our PVKIT components are pre-assembled, the PVKIT itself. But then, because all the brackets are going to vary depending on the roof, you would basically mount it to the bracket on the ground, and then you can install on the fly. Here you see with the red dots and the orange line, you're basically laying out your bottom row of PV kits. And then it's a lay in place situation. Lay your first module down, grab your next PV kits, and it's lay and play. No more spacing, no more measuring it out. The module itself is the jig and showing you exactly where the system needs to fall in place. And when it comes to speed and accuracy, that's our roots. Is all designed, by us and with metal roofing background and contracting background, and figuring out, efficiencies and best efficiencies. How do you get things up quickly, correctly? And Bernie can attest to this, but this was just recently. I'll let you talk to this, Bernie, a little bit.
All right, so what you can see is our current record breakers. I run training for the industry here in New Zealand, mechanical, electrical for solar, and one of the things that we do is we give attendees an insight into the different fixings that we do and different types of rail and railless types of installation. So it turned out we have a competition running across the country every time we do this. So the criteria is that we install a kilowatt of rail version and landscape versus a kilowatt of railless. And the current record holders did this yesterday, and big shout out to them because they are actually in the room next door. It's part of our 2-day training event. I managed to put a kilowatt up in a little over 3 minutes the first time they ever touched the product, and did an incredible job. And what we've been seeing is that consistently across the last 12 months, 18 months when we've been doing this with teams, is that very seldomly does anybody get past 4 to 5 minutes in terms of putting that railless up. And, if we're doing the honest truth, we're doing a rack and rail system. It's going to take us, around about 17 to 20 minutes to rack it, another 4 minutes to panel it. So, we're 20 minutes ahead of the game per kilowatt, no matter how it shakes up. And I've seen this from, in the training room that we do, and right out to the field. It's once we've got our first column in place, it is stack and play. It is very simple and very quick. Installers, as I say, are using this. In fact, is the best kept secret. It's a real competitive advantage. So it's worth getting your head around.
Yeah, and it's interesting that you say that. We have installers here in the U.S. that will use our product, and they kind of want to keep it a secret because it helps them underbid their competitors. If they get into a competition war on a certain project, they can come in much less, strictly from a labor standpoint.
Yeah, absolutely. I think I see that, as in the distribution world, we are constantly seeing stores out there comparing apples to apples, looking at cost per watt between rail versus railless, and they simply forget to add in all the significant savings, which we'll go over shortly, regarding how we attribute that to cost per watt, because obviously the faster you've got modules down and connected and cabled, the faster you're finishing jobs. I think it's a real thing that you have to focus on.
Coming back, so some of the feedback that we've got and some of the questions that we get is, okay, well, if we get rid of the rail, the system's going to be closer to the roof. And what are the implications of that? The 500 TPV was designed specifically to get the back of the glass to 100 millimeters or above the roof surface. The bottom of the module, as you'll see, is somewhere around 67 millimeters, but what's important is where that back of the glass is lining. We get this question a lot and want to kind of dive into it. So let's look at a railed system on corrugated metal roofing. What's advertised over here to the right is 89 to 104 millimeters clearance, and that's getting you to the bottom of the module. And that's from, not the valley, but the high point of the rib. When you come down to the valley, you're looking at more like 106 to 121 millimeter. But how come nobody looks at this right here? If we're talking about airflow, that rail is acting as a skirt around that module. Therefore, you're really looking at 56 to 71 millimeters of air clearance. So just kind of trying to look at it from an apples to apples standpoint. How high you get the module is one thing, but when you have an effective skirt going around the system with that rail, are you really getting the clearance that you want to get? Some of the other products that we have, this is our rib bracket line. We have rib brackets 1 through 5 now, designed to fit all kinds of the various rib profiles. They have flex within the bracket, so they can accommodate more than what you might think. The rib bracket 2 specifically designed for your trim deck style profiles, where our rib bracket 4 is specifically designed for profiles like your Kingspan insulated metal roof panels, the KS1000 and whatnot. This product is designed, everything that we do it so that it outlasts the roof. We haven't done our job if it can't outlast the roof. And so the screws themselves that fix into the roof, if you can imagine what generally will determine the service life of a metal roof, is the fastener securing that metal roof. Once that fastener is done, the roof is done, or you're replacing all the fasteners and putting a bigger diameter fastener in there. These screws are specifically designed for a sheet only attachment. They have a stainless steel cap with a stainless steel washer, EPDM gasket here, and then there's an EPDM gasket within the bracket itself. That's maintaining as kind of a belt and suspenders approach, but it's maintaining water tightness as well as service life. That stainless is going to outlast the roof itself. And so from that standpoint, it's going to outlast the roof, like I just said. But also, I don't have these slides in front of me, but we specifically designed it for sheet only attachment, which means it doesn't drill into the roof, it pierces the roof, which creates kind of a sleeve that gives you better thread engagement, and it increases your pullout value as well as your stripping torque. And another big plus is there's no swarf. If you drill out on that roof, you're going to leave little shavings on the roof. This fastener does not leave shavings on the roof. If one of the rib brackets isn't going to fit, then we have our Protea bracket. Protea bracket is versatile. It's on a hinge, and it's going to fit everything that our rib brackets won't fit. There is a little bit of a cost consequence there, primarily because it's welded and there's a lot more machine time, or not machine time as much as man hours in constructing that part. But it is universal. It's going to fit just about every trapezoidal sheet that you can imagine out there. And it's versatile in the sense that if you do want to use a rail, it works as the L-foot, or you flip that L-foot around and it'll work with our PVKIT as well as bottom mount rails. And again, going with airflow, the space that we created within the rib bracket was designed so that it gets the module glass up for optimal airflow. Factory applied EPDM, those screws with no swerve, maximum stripping torque, and as well, we have somewhat of a cable management channel here if you want to use it within the throat of the rib bracket. Another thing that's handy is if you put a hole in a metal roof, you want that product to stay there. And let's say that you missed it and you're slightly off wherever you put the bracket. It has forgiveness because the hole in the top of the rib bracket is a slotted hole, which can give you about 3/4 of an inch of adjustment. So it's not the end of the world if you miss. Coming back to airflow, again, because this is something that we're constantly discussing. People want to get systems way up there, and that tends to be an engineering nightmare when you get the higher up you get. This is a study from Science Direct that is showing that it can be concluded that a width greater than 50 millimeters has no additional effect on temperature of the module. If you can imagine the airflow that you're trying to get under those modules is to increase the efficiency of the module. This study is showing that the higher you get is really minimal ranges as it relates to temperatures on that module frame from the convective air climate. Logistics, Bernie, you and I can tag team logistics.
Absolutely.
I'll chime in when you're not chiming in.
Sorry. So what you're seeing on this back of this trailer here is 250 kilowatts of rail and mounting components. And look, it's one of those things that is a part of our industry. You've not only got to transport it, you've got to keep it on site, you've got to stack it, you've got to get it up to the roof. It is a lot of product to move anywhere, and as most of you know at the moment with our wonderful logistics industry and the effect of COVID is that shipping costs for everything has incredibly increased, making it, racking systems, they're going up. I think here in New Zealand, because of the freight, you're seeing an increase in rails of $4 plus, just based on freight alone, and that's largely due to logistics. So if we take that and compare that to what a 250 kilowatts of a PVKIT looks like, in the next slide. Oh, sorry. Well, the weight size of that is, 2.1 ton essentially of racking versus 341 kilos in the back of your ute. Everything can go in a box up into the roof. No more cutting, no more storage. Simple stuff on site that makes your life, as we all know, managing installations in the commercial field, you've got a whole bunch of things to worry about, and logistics is one significant part. It's a less of a crane lift, one less crane lift for the racking system, which is fantastic.
Yeah, I mean, it's the same size system right there. Rail versus direct attach, all fitting right there in the back of the ute. And for those of you who don't know, that's James. He works at the plant there. He specializes in making sure that everything runs pretty efficiently and cutting all the material to length.
So if you look at this picture, this is typically how we receive racking in containers. You're seeing 840 kilowatts worth of racking sitting in front of you in one bundle. It's about 1,700 kilos and about almost 5 cubes. It stacks up. In a container, we can only realistically fit 8 stacks of rails. So, 1,960 rails in today's talk. So it's one of those things, where we had to look as a logistics organization on how we do that. And the number one damaged things in shipping, as we probably all know, if you've received it or sent it, is damaged rails. Freight companies hate them and love to damage them. So it is a real bugbear. And I'd love to be able to send the equivalent. In the next slide, you'll see the same amount of rail.
Yeah, just to chime in though, what you're looking at the left, like that's 840 kW worth of rail at 4,200 kg.
Ta-da.
And so,
yeah, it's an incredible weight saving, and of course, shipping around. As I said earlier, shipping around the country is incredible. I mean, it's 15% of the weight. It really is one of those calculations you have to add into your cost per watt, because logistics hurts us all.
So going into this slide here, make sure I don't go too far, but in terms, it's hard for us to say what the savings is on hard goods. We have competition all over the world, and we see prices ranging dramatically from rail manufacturer to rail manufacturer. But things that are quantifiable is your savings in labor at being 30% or greater. Savings on freight, 60% or greater. Bernie touched on that a little bit. Sounding like it's more on the greater side. Weight savings on the roof and transport, 85%. Space savings, if you're warehousing this stuff, if you're an EPC that keeps stock on hand, you're looking at 90% space savings up on the job site, getting things to the job site. It's incredible. Improved load distribution to the structure at 25%. Now that one I can dive into a little bit greater, but you're actually fixing the module more frequently when you're using a direct attach system, which then improves the load distribution into the roof itself. So those loads are shared between the roof more so than if you're point loading the structure because you're spanning a rail at greater distances. So overall, your savings in logistics is massive.
It is, and one of the things we've seen is recently the massive switching to the railers for those who have ventured into this purely on the saving and logistics and the ease of handling, the speed, you name it. It's really a huge competitive advantage, and you start to stack this stuff up, and it has a significant project saving. It really is everything it's cut out to be.
Cable management, this is Bernie's specialty, especially because he's in your part of the world where we have very similar code and regulations. There are some slight nuances, and I'm going to let Bernie kind of take this one.
Look, we're dealing with multiple technologies today in solar, whether it's a microinverter system, DC system, optimized system. There are AC embedded modules. We have cables to contend with, and we have to control them. We have to comply with the standards in terms of, making sure that everything is mechanically secured. And, one of the things that we're all used to as installers is having a rail to tie everything to. But in looking at some of these slides here, microinverters are a little bit more challenging than DC in terms of the way that we mount them, but completely doable. We manage everything with clips. And one of the things I have to state about wire management or any cabling on an array is you shouldn't be turning up to a job and this thing being a surprise. Cable management is a forethought, not an afterthought. So we very, very strategically think about stringing arrangements for DC or microinverters, where our cables are, how we're going to control those. And the simple answer you can see in all of these photos is clips. There are an amazing array of clips available out in the world, which we'll get to shortly. So can we go to the next slide there, Dustin, please? I don't need to tell you how PV strings work, but we need to be able to control them. So what you can see in the bottom there is the older version of module where we have the junction box at the top, and we're jumping into the new cell modules with split cell type of scenarios with our junction boxes either in the center or top and bottom. You name it, we can deal with it. So everything we can do, we can manage with cable clips. And it's simply thinking about rails in a different way. Every panel that we work other than frameless has rails built into them. So we utilize those. So we can go to the next one, Dustin, thanks. Isolation is probably a big question from Australian installers. And New Zealand is not required to have a DC isolator at the rooftop. However, in Australia it is required, and now we have to put them in the pie warmer, as we all know. So it's very, very simple. We use any specific manufacturers out there have them. We're not reinventing the wheel on that. But what we have is the ability just to put our bracket But you can see a coil bracket there or a trap bracket on the bottom of it, and we use a little bracket and fix it to the roof and connect there. So very, very simple. So nothing that you're not used to already. It's just missing the rail. Next slide, Dustin. Look, as you can see here, that there are some critical rules that cables are not allowed to lay on the roof surfaces, and they have to be held up in a way that debris flowing under the array are not going to grab cables and dislodge them. We're not allowed to use plastic cable ties. Very hard to use stainless steel cable ties on the frames and modules, but clips, you can get them in 2, 4 types of scenarios. Do pretty much everything. And the bit that the PV kit has on it also, the PV disc also has slots in it to allow you to cable tie if you need to use cable ties onto that. So it is a very, very well thought through product. And as you can see, some of the industry leaders in Australia have already seen the value. See Glenn there giving it a red hot go on his energy centre there in Victoria, and loves the product. Next slide, thanks. So cable clips, welcome to my world. And even when I'm using, we're training for DC systems, whether we're in rail or railless. In fact, we teach people how to use no cable ties whatsoever. It's always clipped now. We have, every time you put a cable tie onto a rail to hold onto any sort of cable, any movement of the array, removing modules starts to become problematic when we're lifting them up. So I found that clips is a really easy way, and particularly with the end phase, we've got to have the right type of clips for the PV kit. But it's a real revolution, really does. So we have every manufacturer, it doesn't matter what clip you're using now, or module manufacturers recommended clips, they're available at the market, and just get using them. They're fantastic. Next slide, thanks, Dustin.
Yeah, and something else with the cable clips is, at S-5, we've worked pretty diligently at trial and error on the various clips that are available and how they work, how well they stay on modules, how easy they are to install. And we've narrowed it down to where we're actually making what we consider the best of the best cable clips available with our products as well.
So one of the when I found the PV kit in the US a number of years ago, one of the things I quickly realized is that there is a big difference between the earthing compliance and ours, and it was quite an interesting thing that we had to think our way through, and it took a little bit of doing and a little bit of searching from some of the systems I'd seen around the world. We're all well aware of 5033 and what's required, and the bugbear in that is that if we remove one or more PV modules, we can't affect the continuity of earth or bonding to any other module. Now, in a racking system, that's really easily done because we're using weaves and whatnot. So that is a very simple way. But S5, we've got no rails to do that. We have quite a unique system, and we've got one more step that we do here, which is very, very simple to make this completely compliant. So if we pop through the next slide, thanks, Dustin. We all know the traditional earthing system. It is bonded earth to the rails, and then for our modules, we have a weave washer, and we can do that in multiple ways to make that compliant. So we move one or more modules that we don't interrupt earth continuity. However, in the next slide, you'll see that with earthing the PV kit, it's 3 easy steps. So we lug, and we're all used to doing that in one way, shape, or form. The only difference is that when we do our initial lug onto the first module, that we double lug a earth that's going to run the perimeter of the array, so that if the first panel ever came off and we unbolted that earth, it is still connected to the modules behind it. So the system we came up with is very, very great. It's used in Europe a lot, and it is just a simple clip that slides onto the side of the panel and just gets clipped into place. There's no more stripping of cable. There's no more gulf spraying. The clip itself will pierce the sheath of the earth cable and come in contact with the conductor, and as it scrapes onto the module frame, it cuts through the anodization and seals. Now, if we ever had to remove a module, we just pop the clip off, and then when we reconnect the next module, if we're replacing a faulty module, we clip it back on. The next slide, please, Dustin. So the PV kit itself is completely UL compliant. What it has is every part of it has been tested to transfer earth module to modules through the disc, and then of course through the complete body of the PV kit. So you can see an example here. You may have a batch problem with modules where we've had to remove 4 modules out of that array. And if we use what we call a bonded jumper between the modules, we can still make this comply. However, if we remove one more module in that string, we're in a little bit of trouble. And in particularly if we're using a vertical stack or one vertical column of modules and just relying on the earth disk, we have a problem if one module is removed in any part of that. So we use an earth wire that runs up the side of the array and around the perimeter of the array, and we clip it on with one of the earth clips. And then if we ever have to remove it, we're completely within compliance to both the Australia and New Zealand standard.
Yeah, something that's important that is missed is the disk itself functions as a weave. So you've got continuity from module to module to module. Wherever there's a disk, you've got continuity. What we're looking at is, okay, how do we jump columns where there's no weave? And that's where this bonded jumper comes into play. But sometimes you'll run into a situation where, let's say a module on the end here is removed that had that bonded jumper. So you remove the bonded jumper, you could disrupt that earth path, unless you're fixed at both top and bottom, but there's some other nuances. With this other product down here, you remove the clip and your ground path stays continuous. So imagine that wire is how you used a rail in the past. It's keeping everything continuous, and it's costing a fraction of, if you're running rails specifically for earthing compliance, that is one very expensive earthing component.
Yeah, if you go back to earlier where we talked about, the example of a $20 rail, and it's $17 of that rail is just earthing and of course cable management. We all know how cheap clips are, so it's very simple to use. And these clips, Dustin and I are actually working on an easier earth clip to use, a more that's quicker and simpler. And there's nothing wrong with the current one that we're using, but like everything we look at in the PV kit is to make sure that the installer experience is about being able to put modules down compliantly and at pace without any hiccups. So it's a wonderful thing. And look, we've tested it. It is compliant. We have systems all over New Zealand, of course, and Australia now using the PV kit and all passing earth compliance.
Yeah, and I mean, what Bernie touched on just now, I think is important. We don't claim to know everything, and we get side by side with our installers. We get side by side with our distributors, and if there's something that we can be doing better, then we figure out how to be doing that better. It's continued innovation. It's continued making your jobs easier, more efficient, and more affordable with the products that we have.
Yeah, absolutely. And it's about removing it's not just about removing cost for us. It's removing, physical stress to your body, safer installations. It's something that has been well thought through, and this is not something that has magically appeared. Has been around for a number of years. And S-5 and the PV kit, it's probably one of the only racking systems in the world that has a lifetime warranty. I don't think too many manufacturers come up with that claim. In fact, most manufacturers haven't been around long enough to prove their warranties.
Especially as the solar industry goes, you see a lot of solar companies come and go. We used to have a 25-year warranty, and we're one of the few companies in the solar industry that have outlived their warranty. Within the last 2 years or year and a half, we've bumped our warranty from a 25-year warranty to a full lifetime warranty. The reason being is like I said, our products are designed to outlive the roof, to outlive the system. If we don't have a product that's going to last longer than whatever's being attached to that roof or whatever that roof is, then we haven't done our job. I put a pause right here for questions because this tends to be where questions funnel in. we still got plenty more to share with you. I can't see, what we're getting in terms of questions. I think Mark can, but I don't know if there's any questions that have popped up that we can answer live right now.
Yeah. Hey, Dustin. Yeah, there's a few I can. Well, let me just reel off the questions for you.
Yeah.
I answered a bunch, but there's some that I think you're better to answer. And one is where you and Bernie can say, where do you buy this product from?
So the last deck, we've got distributors kind of all over Australia, and within New Zealand. Trade Zone carries our product. Mac Fasteners is carrying our product. RFI carries our product. RSS, Matt Hennessy and team over there, they're killing it as it relates to getting product out and getting it out there affordable. And Solar Partners there in New Zealand is carrying as well.
If you're an installer across New Zealand, you have a power-based store close to you, you'll find S-5 products on their hot shelves as well.
Cool. Here's another one. How are you installing rooftop isolators?
So isolators, I can jump back right quick. I love what you call it, Bernie. That's not a term. If you can cover that again right quick.
So as you know, out there, most racking manufacturers supply some form of isolating cover to comply with the standards. We're not going to reinvent the wheel on that, and it seems that DC isolation is going to disappear for rooftops shortly in Australia, as I understand it. So, typically you're seeing the traditional type of DC isolator cover. What we do is just have a little bracket that sits at the end of it, and we attach whatever S5 product that you're putting on below that to stitch it to the roof. So it just sits outside the array. So very, very simple. So nothing you're not used to using. You fix it the same way as you fix the PVKIT with the brackets you have. Very simple, very quick, very easy.
And there were a couple questions on certification. One was, what are we? Is it compliant to the Australian standard? And then another one about CEC certification.
So yep. So the only bit that was the stumbling point when we first brought the product to market was looking at the earthing compliance to 5033, and that's the reason we use the clips and the way that we do is to comply with that. So yes, it meets both Australian and New Zealand standards.
So as designed now, including the way we earth, it is in compliance.
It is in compliance, and including, I think it's probably worth touching on. We may have a slide a bit further on, and also spacing arrangements and engineering around that. So the same stuff you would see from GAMCore for other racking systems, S5 has the same type of spacing arrangement calculations for their products and the roof that you put it on.
What about CEC certification?
Clean Energy Council certification, so it's compliant with the Australian New Zealand standards, so therefore it's compliant with the CEC.
Yeah, and it's a bit of a misnomer. I mean, the CEC doesn't necessarily approve products.
Okay.
Just so that's clear.
So they do have of course, the CEC has their approved installer and module list, but the racking systems come down to a different part of the standard.
Okay. There was one quick question about clip lock system. What do we have?
Absolutely. Yeah. In terms of clip lock's concealed fix, and that's our bailiwick. That's what we do. So our K grip is designed specifically for clip lock. I'll get into that here in just a little bit.
Okay. And then there was one other comment that the slides on earthing and cable management are great. Thanks. Do you have any tech notes on the subjects of cable management and earthing?
We're working on a document now that'll make it significantly clearer for everybody.
That's great.
what we hope to do is, as COVID disappears from our lives, is to be more present in the market, doing live installation training with installers and around the different states in Australia, just so you can get hands on, because we feel that the best first experiences was having been guided by someone like us to get you through. And we can do this remotely as well. So if you reach out to us, if you have projects, we're more than happy to jump on FaceTime with you and walk you through every part of the process. It's very, very easy.
Yeah, absolutely. I mean, before COVID hit, right when COVID hit, I was there with Bernie, and we were queuing up to do a lot of training and things like that. And that's going back, March 2020. And the plan is S-5, I was going to be there with y'all, working on jobs, getting up on roofs and everything like that. And then COVID hit. And so we've gone to this platform to some degree. I've helped with installations via FaceTime. I prefer not to do it that way, but it's something. And we're queuing up modules, training modules, videos, things like that, until I can get back to you. Those are what we're doing, as well as we're also, New Zealand and Australia have opened up. And so we have more flexibility in that realm to really, help with the hands-on experience.
So one last question.
Oh, you got another one?
Yeah, one last question just about issues with portrait-mounted systems. Any issues with that? And I could answer that, but go ahead.
You can mount portrait.
Right.
You can, but the module producer, you got to look at what module you have and if you can mount on the short side of the module. More and more, you're seeing module producers allowing you to mount on the short side of the module, and it's not a big deal. On a corrugated roof, you've got every 76 millimeters, you've got essentially a rail to fix to. So it's endlessly possible to grab wherever you want on that module. But grabbing in portrait on the long side of the module is not a good idea, because it's not always going to coincide with that 76 millimeters.
Right.
What I encourage people to do is look at landscape. I've been extremely impressed where I'm seeing, like I showed that rail system earlier, a lot of systems are going up in landscape, because in more times than not, it's more practical, and especially more practical with a metal roof. You flip the module around and you'll see often you can get as many or more modules on that roof just by flipping it the other direction.
Yeah, exactly what I would say. And then somebody asked about, we install in North Queensland. Is this fully rated for cyclone wind rating?
Yeah, I'll jump into that once we get into the testing and stuff like that. So I'll cover that here a little more thoroughly in a minute.
Okay, sounds good. That's it.
All right, so jumping into testing, we do a lot of testing, and the reason we do a lot of testing is because, as you can imagine, our product's going to perform differently on all the various different roof shapes, geometries, material thicknesses, etc. All of our products are produced in an ISO 9000 certified manufacturing facility. That's our facility you see there in the background. That PV array that's on that was actually installed by the R&D team with the prototypes of our PVKIT 2.0. Everything we do is certified raw material, and then on top of that, we have various listings and certifications with UL, Factory Mutual, the ICC, TÜV, and SAI Global, as well as even Intertech now. We add to that constantly. So we then have to maintain that certification, which means our factory is being audited by all these different entities for quality assurances. And so we have a 0 defects policy, and we live by that. Here you see some of the certifications that we have. KIT was the college there in Germany that ran some of the tests that got us our German approval with the DIBT. We ran some cyclonic tests as well as static load tests at the University of Adelaide. You see LADBS, County of Los Angeles, etc. We strive to make sure that the toughest jurisdictions in the world have familiarity with our products and are comfortable with our products, and then we get the certifications to back that up. Within UL 2703, we test specific to the modules. So we're testing our product specifically to various module producers, and we're adding to that list constantly. In fact, there's probably 5 manufacturers that you're not seeing there, but Canadian Solar, Yingli, Trina, SunPower, Q-Cells, Jinko are all part of our certification right now, with our products being tested specifically with their modules. To give you a better understanding of what UL 2703 is, UL 1703 is module testing, which is specific to the module, understanding what strength the module has. Then you have the IEC 61730, which again is module specific, which has some various parameters that are slightly different than 1703. Where UL comes into play, UL 2703 comes into play, is now we're looking at a combination of the module and the racking components. And those systems are tested specifically with one another. Here you're seeing a simple sandbag test to quantify, when we're grabbing on that module at a specific area, how the module is going to react with our interface. And within that, you're looking at downward pressure, upward pressure, as well as down slope pressure. We get constantly asked about water tightness. We run some of the most stringent tests that you can imagine in the industry. The big one is ASTM E2140, where the assembly where the fastener is submerged with 6 inches of static water pressure. And that's done for a period of over, I believe it's 24 hours. If there's a single drop of water, you fail the test. I always tell people that this is a pretty strenuous test, because if you're ever in a situation that you have 6 inches of static water pressure on your roof, you got more things to worry about than a leak. But that's the kind of testing that we do with our penetrative solutions. Another big one that we get is using stainless and aluminum on zinc aluminum. So we showed you earlier how we have an endorsement from one of the inventors of zinc aluminum with our products on that zinc aluminum coating, but we do get some pushback every now and again saying they're not metallurgically compatible. So we ran an ASTM B117 test. What you're seeing right now is a zinc aluminum roof that had clamps placed on the roof with the stainless steel set screws right here on the right. You see the little dimples. And that's after 1,000 hours. We removed the clamp, looked for any premature corrosion on either the clamp or the roof. Couldn't find any, so the test is typically a pass at that point, but we went ahead and said, well, let's see when something bad happens. So we ran it toward 2,000 hours. This is at 2,000 hours. You can see there's almost nothing left of the roof. However, the clamp integrity has remained intact. In fact, it kind of protected the roof at that area. You'll see on this bolt here, this is a 300 series stainless bolt, A2 stainless, that there is a little red rust markings. Typically, after that long of a period in a salt fog test, you're going to see something like that. That has more to do with the tools that created the bolt than the material of the bolt, meaning there's some oxides that got onto the bolt from the iron tooling that created it. This is a test we ran in assembly at in Cologne at TUV. And what you're seeing right now, I drew that line there so you can see where the module started. And that's at 2,500 pascals. You see we got a pretty good bow in the module. The brackets are holding on just fine. We bumped that up, ran that to 4,500 pascals. You see the significant arch within that module. We intentionally mounted these on the far ends to basically try to force a failure within our brackets and strain the brackets as much as we could, as well as strain the module. We still didn't see a failure. I believe that ended up failing at somewhere past 5,000 pascals, where we bowed the module and actually we didn't We separated the clamp from seam, but when the clamp went, so did part of the roof. And this was 032 aluminum. So if you can imagine, it's pretty light gauge aluminum. Our policies is 0 defects every single time. That's why we do what we do. We know who we're competing against, and we know what you suffer when you get to a job site that's pretty rural, and you've got product that's just not working. As Bernie mentioned earlier, damaged in shipping, et cetera, et cetera. We have a 0 defects policy. So we maintain that nothing comes out of our plant that has a defect. Should something come out of our plant that has a defect, we have massive procedures to make sure that it never ever happens again. And we make dang sure that the customer is always taken care of. And I'm proud to say that that very rarely happens.
One of the nice things that you receive when you receive any boxed item from the factory in S-5 is it has always a little label in it with a handwritten signature, and who checked why and when. It's a beautiful personal touch. I mean, I have to say that I haven't seen too many manufacturers that take to the level of detail, giving great customer service and ensuring their products get to you in perfect condition. So I've moved a lot of the product and we've never had an issue ever.
Yeah, and I mean, as you've seen previously in that video, it's not our manufacturing team is our family. And everybody operates as a family. And so everything that we do is done in such a way that there's a level of ownership from every department, from every stage in the game. That's why you see signatures on boxes that says, I'm so-and-so, I check this and I certify that this is good. There's a date on there. With every procedure that we have, there's a sign off, a level of ownership within our staff that, we care. We own these products, and we want to make sure that nothing bad happens that's going to ruin somebody's day when they're out on a job. And we put those levels in place to make sure that happens. Another thing I kind of want to touch on is when we get involved in an industry, we don't just get involved on a sit back and listen to see what's going on kind of level. Mark's on the phone call here right now. Mark and I participate in code development, designing, helping influencing code. If code is short somewhere and they're not listening to the installers, then we sit on the committees to help draft the language to go into the International Building Code that is going to hear the installers. Here you see just a few places that we participate in. Underwriters Laboratory is a big one that create the test methods in which modules are tested and racking components are tested. And, we serve within those standard technical panels to make sure that A, the installer has a voice, but B, that we're able to facilitate that. And then on top of that with SIA, the solar energy industry here in the United States, I serve as a chairman. Mark's a co-chair, where we represent the PV mounting system manufacturers committee, which, what would you say, Mark? That probably consists of about 30 to 45 different racking component manufacturers. Some are competitors, some are friends and allies, but we're all serving together to better the industry as a whole.
Yeah, that's about right. And it is a good group of people who are really dedicated to evolving the industry, not competing with each other.
Yeah. Again, more industry memberships. We're heavily involved with the metal construction industry. That's our bread and butter. So we're with the Metal Construction Association, the Metal Building Manufacturers Association, the Metal Building Contractors. We know metal roofing and metal construction better than, I would say, any other racking component manufacturer in the world, probably times 10. S-5 installation best practices. Bernie, I'm going to let you touch on this one because I think you sum it up quite well. It's got to be a forethought, not an afterthought. You don't want to show up to the job with the parts and be like, now what?
Yeah, exactly right. I mean, there's a lovely list of things you should do, but here's one of my major tips is that jump down to your local distributor who's pushing this product into the market there and put together a little sample kit for yourself where you're carrying one of each of the rib bracket, any one of the clamps, so that when you go to site, when you're scoping the site or looking at the job and how you can use the product, is that you can actually physically eye the product up onto the roof material that you're going to, so that you don't turn up to the site with the wrong product or order the wrong product. So a little sample kit, and most of my clients across New Zealand carry these, and it really makes their day. And if they're not sure, they can take a photo of it directly and send it to myself. And if I'm not sure, I'll send it to Dustin. And you have an answer typically within 12 hours of what you need. So the key is, get into some training. Sign up, talk to your local distributor. As soon as Dustin and I can travel to Australia safely, we will be there doing live training. And if you've got a project specifically, don't wait for COVID to clear. Talk to us directly, and we can help you via the web. One of the issues I've seen across with new installers for this product is they don't correctly identify their profile. Well, if you can get the spec sheet or take some photos and some measurements for us, the experience that the S-5 team had, I sent it over to Dustin and Mark and the team, and they're quickly able to identify and give some suggestions, and then we'll narrow it down and obviously nail it down to the right bracket. Understand your spacing arrangements, grab a hold of the documentation that's available to you. This is no different than we're doing any other day with traditional racking systems. We are still having to design around the wind loads that we're working with, the roof material that we're working with, and all of the things that we do on a day-to-day basis. We're just removing rails from our lives. Plan your layouts. I mean, great designs and great outcomes come from great planning and great forethought and turning up with absolutely everything you need. As you all know, you're all experts in this field, and our days always go better when we turn up and nothing is a surprise. And the key, I have to say, and I know Mark is going to be nodding his head, is that cable management is all about pre-design, turning up with a strategy and executing on that every time. Look, we all deal with optimizers and micros. There is a very simple way to do this. Dustin and I have been, working very heavily on coming up with specific clips and whatnot from around the world to hold on to the larger, trunk cables that we're seeing out there. Optimizers, the same thing. It comes down to good planning. And thinking about our clearances, in New Zealand, there's a real concern that racking systems or modules should need to have a minimum clearance of 100 mils so that you can clean under them. Otherwise, you avoid the warranty of the roof. In Australia, it's around about 50 millimeters, and that's you've got to have that clearance. For not just the the cleaning of the roof and the maintaining of the modules. It is to do with thermal loads on the arrays and whatnot. So great installs come from great forethought and using the right products for the best fit for the environment that you're in. So, whilst the product isn't great for every installation, but when it comes to landscape, if you're doing landscape, you really need to have a think about this. It will change your life in terms of your install world.
And some things that we do to help out, we've got a solar manual that we're updating constantly. In fact, it's under its revisions right now. That'll help you identify what bracket you might want. We talked about clip lock earlier. You see on the bottom right. We have now 3 products for clip lock style roofs. The most popular is the 700 and the 406, which is our K grip. We also make a D grip because Diamond Deck and some others over there in New Zealand make a much larger clip lock style roof, where we have a product for that as well. And all this is within our user manual, but we also have a configurator within our website. If you go to our website and you click on the configurator, we're going to be able to show you what clamp to what profile that we have experience with. And then again, identifying if you don't know, you're on a job and you're like, I don't even know the name of it. We handle those all the time. send us a cross-sectional drawing like you see here, or a photo with a tape measure on there, and we can generally figure out exactly what product you're going to need for that specific roof profile. Somebody asked about cyclone regions and whatnot. We work with GAMCOR to determine spacing arrangements. So GAMCOR is going to look at our specific testing on all the various roofs, whether it's Lysot's long line, or Stramit's snap tight, or Fielder's snap lock, or Lysot's high strength clip lock. We have all those roofs specifically tested. We then send that information to GAMCOR, and GAMCOR will come up with spacing arrangements like you see here, that are then used so that you know exactly how many clamps or brackets and how frequently they need to be spaced. We do this for our PVKIT as well as for rail support systems, utilizing kind of a lightweight generic rail. And then we also look at tilted systems. I know in the years past, everybody was wanting to tilt. Module prices fell down. It made more sense to just cover more square footage of the roof than it did to tilt them up. But we've got all that information there. And if it's not something that you see within our manual or something like that, get in touch with us, because 9 times out of 10 we have it. And if we don't have it, we can get it relatively quickly. And here you see, some of the information from GAMCOR, wind regions A, B, C, and D, 200-year cycle. We did run this on, you notice modules are going larger. I'm sure Bernie can talk about this more, but that square meter, 2 meter by 2 meters was the largest that we could find, and we ran most of our engineering around that, specifically because it gives you more conservative value, but also because we know modules are growing in space and size. And so we have those spacing arrangements even for, the biggest of the big modules that are coming out. Another question was authorized distributors. Here you see a list. They're in Australia as well as New Zealand. That's yeah. And that's my last slide. So if we have more questions that have funneled in, happy to take them. Let me end this and get back to where I can see everybody.
Dustin, can you leave that slide up for a while? Yeah. I know they want that way they could copy the info down.
Yeah, so I answer them all. There's no outstanding ones. One person was asking about when installing in landscape orientation and in using string, is it good to use what's called a return cable for the conductors? And my answer was, you can answer Bernie as well, but I said, yeah, it's very common. We see this all the time where people have a return cable when they're putting together a string. As well, we see where, as you said, if you strategically plan your string ends to be close to the perimeter, you can route the conductor and a jumper to the perimeter. Then once it's in the perimeter, you can run it along that edge. It takes it easy to the home run. But that's common, but we do see return cables fairly common. I see them a lot.
Yeah, absolutely. And it's just a different thinking, because everybody's used to getting the home run strings ready and prepared, tied to the rails and ready to go, so you can finish at either end. Well, all you're doing is just pushing it out to the edge of the module, the edge of the array, and bring it up the outside for easy access, easy maintenance, easy clipping. You don't have to add actually any more clips, pigtailing clips holding your cables up the module. You can just absolutely clip it right in there.
Yep, sounds good. Then there were I had answered a couple questions that were related to more comments about how, is using the PVKIT, how do you adapt to wavy roofs, I guess, and what's the difference between the rails? I mentioned the Protea bracket does have some vertical adjustability to allow to adjust for the waviness, but I don't know if either of you want to comment on that.
Yeah, look, from what I've seen out there, in landscape, typically, the waves in most roofs run along the roof. And with the PV kit using a typical metal fixed bracket, you're not going to be able to get a lot of the linear waves out. And it's something you don't have to pay as much attention to as you would do into rails, because if you're putting a bend in a rail and forcing a panel to bend with the rail, there's the problem. The PV kit is just grabbing on the frame and is levelizing itself across the roof. So it really, from all the commercial stuff that I've seen out there, that has really been a very little problem.
Yeah, I mean, it's going to follow the roof. If the roof does a little bit of this, like what Bernie's saying, if you're running a lineal across that and you've got huge dips, you're going to have a hard time bending that rail down to follow the curvature of the roof. We're fixing, in landscape in small sections, and so it's literally going to follow the roof. If you're worried about aesthetics, I've not seen ondulation so bad that it was something that you even noticed when you're looking at a PV kit install with a roof that's way out.
Yeah, I understand the, all installers, we're so used to using rails and trying to get that horizontal plane better than the roof above to stick the modules on. But it's all about making sure that, you're not artificially putting pressure into the modules across that rail, because if there's a banana in the rail, and L feet only have so much movement. And the issue with, if you are taking undulations out of roofs, taking peaks and troughs out, if you're dropping the rails at one end, you can absolutely reduce the airflow under that array, at the ends or in the middle if you're just trying to take the cup out. The beautiful thing about the S-5 right along there is that it's keeping that module at the same height right across the roof, ensuring that we get, equal airflow.
Sounds good. Then there were a few questions, and one just popped up, and maybe you just want to reiterate options for MLPE, what all that means. I know you talked about it.
Let me jump back into that web presentation and show that.
It might be worth reiterating.
So one of the things, and we've tried a number of ways of doing this, what we found is what works the best with module level power electronics, whether it's an optimizer or micro, is going directly to the frame of the module. I know Enphase creates a bracket that makes that easy. I think SolarEdge does the same. Going to the module has so many benefits. If you can imagine, when you were doing it on a rail, you're spacing the rails out, you're mounting your micros on the rail, and then you're making sure that you had to do a lot of thinking ahead of time to make sure that all your modules are going to line and fall directly over that micro, etc. This lets you do this all on the ground. You bolt it right to the module frame. You do your wire management right there on the ground. When you hand that module up, or when you pass it down, or however you're doing it, you're simply just clicking it into place, as opposed to doing all the pre-setup on the roof, trying to determine it. You can mount these micros on the roof. That's done as well. I think Bernie and I did a couple installs that way in the days. And
yeah, it is more of a challenge with optimizers and micrometers in the roof. But again, if you turn up without a little bit of pre-planning, it's going to be a complete surprise and a pretty unpleasant installation. So planning everything is the key. I mean, the new modules coming out, we're seeing SunPower now coming out with the Enphase and built in, a fantastic product. So we're starting to get the issues of what we do with the module and the microinverter together. We have optimized panels. So it's about planning. It doesn't matter what technology you decide to put under the modules. It's really about key planning about what you're going to do on that job on that day, because we don't have a rail to fix this, so we've got to think about the placement of the inverter, a trunk cable or a Q cable in terms of Enphase, where we place that, because we only have the limitation of the distance between the plugs, and we have to manage that heavier cable under there. So there are all sorts of clips that you might not be aware of that we've been using and trialing for a couple of years now to make that happen. And it's like anything. The first one's going to take a little bit of practice, and the second one is simple.
Something I want to hit on also before we end, and I don't know if Liv is still on, but I know we had a giveaway kind of thing on
Yep.
this. I don't know if you know the details. What
Did I not win that?
to?
Yeah, that's right. So we'll be, so basically what we're going to do is at the end of this webinar, we're putting everyone's names into the draw, and we'll be drawing out 10 kilowatts worth of PVKIT 2.0 to give away to the first, as the first prize. And as the second prize, we're giving away a smoker or a grill. So yeah, and we'll be doing that as it'll be from Bunnings. So no matter where you're located, you'll be able to pick that up from your local Bunnings.
Good deal. I think I just saw another question coming into pulling a module anywhere within the array. I know we get that a lot. I'm going to go back to it, Bernie, if you want to.
Sure. So, if you missed this earlier on, one of the key issues with earthing, you know, under the standards that we're required to comply to in Australia, New Zealand, different versions of 5033, but essentially says that we remove one or more modules out of the array, we need to maintain earth continuity. So the PV disc carries intermodular earthing without any problems. So that if you're looking to the left-hand side of the screen, about midway down each part of that product, there's a disc and it acts as a weave. So your intermodular is done. Intercolumn is where we either use you see at the top right-hand corner, a little jumper, a UL rated jumper that jumps between the columns. Or if you go back a slide, Dustin, we use a much easier step. So this is something I saw in Europe many years ago, and it's a UL compliant earthing methodology where we earth the perimeter of the array. And so all of our discs or weaves in the PV kit do, again, still doing intermodular earthing, but we need to do the perimeter in case we remove one or more modules in any part of that array that we don't lose earthing continuity. The trick is when you bond or crimp your first earth to star washer and stainless steel bolt your earth to the first module, is that you crimp the perimeter earth into the same. So if that was the module that had to be replaced, repaired for any reason, if you remove that bolt from that module, that the earth will continue in that array. And then when you reinstall that, you just bolt it back in the same way. Same with any other panel in the array. If you had to remove it, anything from the outside, you would simply pop the clip off, remove the module. Once the clip is off the module's free, and the earth continues to the next module. So simply reversing that when you put the module back on by clipping it is the simplest way to do it. And look, you know, we spent a lot of time looking at this, and you know, we have a clip in production to make this even simpler. But right now, it's a very, very simple methodology, and it's done right at the end. So running your perimeter, it's very simple, very quick. And what I've seen out there, teams doing it multiple different ways, but I really think that it still outweighs and out is so much quicker than bonding each rail by chucking, you know, a lug on, earthing it down, now having to put in copper ferrules to keep the earth in place. No more galv spraying, no more stripping. It's really, really a simple process in 3 steps.
So there's one comment in the public chat from Andrew saying, we are definitely interested in using this product here on the North South Wales Central Coast. Is Victoria our closest distributor? Are you planning any direct training in New South Wales?
Absolutely. So we have multiple distributors up on the screen there that service right across Australia. We will be, as soon as Dustin and I are able to get a schedule over there, there'll be some marketing going out to you where you'll be able to see where we're running these training events, and we will be doing it in each state of Australia. So if you're on New South, where was the person located? On the border of New South Wales and Queensland.
Cool.
Yeah, the closest is going to be RSS and Trade Zone, but
yep.
Keep in mind, I mean, I don't need to say but keep in mind, everything is, we made our products affordable and easy to ship. And And so that's one thing that we would encourage to do is go ahead and, you know, price shop it, make sure that you've got a distributor that's taking care of you. I know Trade Zone and RSS are really stand up. Same with Mac Fasteners. I mean, every one of our partners in Australia is going to take care of you. RFI. Talk to them, create a relationship. You guys are really good at doing that, and when we sign somebody on, we're signing somebody essentially back on to the family business, and we go through great lengths to make sure that we have all the right partners.
And on the other side, for the visual, I know how we're all visual trainers, and we're all love to use our hands and give it a go. We're about to do a little video series of filming us doing the PVKIT installation step at a time in our live training center in New Zealand that you'll be able to get access to and follow step by step. But please don't wait. Reach out to your local distributor, grab some product, even on some of the small jobs. Contact us directly, and we will talk you through how this is done, even face-to-face on the day you start, because there's a couple of tips and tricks once you have them under your hat. Very, very simple.
That's it for me. I mean, I wrapped up everything on the questions and comments side.
Yeah, Bobby, just so it doesn't go away or anything like that, we've got logged to the chat, because I've seen a bunch of stuff coming in on the main chat.
Yes, we do have that. A lot of great,
most of these.
Yeah, Mark has, by the way.
All right.
I've responded to most. I've responded to everything pretty much. And some were just comments and great, thanks.
Yeah, Steve there has a project coming up he's wanting to use a PVKIT on.
Let me just ask that about any videos or tips for microinverters. On our website, we do have other webinars that you can listen to that get more into detail on those topics. And there will be more videos to come.
In terms of Neil, you just asked if there's going to be a copy of the slide and stuff like that. As far as I know, we will publish this presentation on our website where you can come back and watch it.
And Lee, I see Lee's asking about tips and tricks for microinverters. Look, get in touch with us directly. It's something I can talk you through very, very simply, because it's the one thing that Dustin and I did many years ago when we first started with this, is that introduce and seeing how we can make it simpler for microinverters. And we've looked around the world to find these tips and tricks and tried them ourselves and have a very successful process and a plan that we can help you with.
All right, hold on. There's maybe one more question. So Rob just asked, best way to torque the clamps or other components.
So it depends. I mean, if you're working on a screw down roof and you're going through the sheeting, your approach is going to be different than if you're with a clip lock. When you're going into the sheeting, it's literally a visual. The way that screw is designed is it's dome shaped on that washer. So when you drive to the right torque, it's gonna straighten out, and you're gonna see a little bit of that APDM protrude, and that's where you want to stop. You can set your gun choke down to where you're always maintaining that, or almost always maintaining that, but it's more of a visual. I always recommend get a piece of the sheet, go somewhere where you can try screwing that screw into the sheet to make sure where you're at. And if you're doing one by guess and by golly, make sure your gun is turned way down, and turn it up as you go till you get to where you want. When it comes to a set screw or a bolt, again, you can set your choke on your gun. You run the first one in, check it with an indicating drive that says, okay, the gun's delivering 50 inch-pounds or whatever it may be. We want to get to 13 Newton meters. Turn your choke up, hit it again, until you're getting to that. And then you don't have to check every single one. You'll have your choke set on your gun, and you know what the gun's delivering.
Many installers have quality audit processes as they build. That should be incorporated into it, as well as checking the torque periodically on your finished screws, set screws, to then just to make sure that you're maintaining that torque. And then one last question, I think. Do you have any photos of the earthing system installed?
The earthing system, in terms of that copper wire with the clip that goes on?
I think so.
If we don't, we will have soon. One of the things when you sell through distribution is we don't always have firsthand contact. But we do have projects where we are pretty heavily involved and can probably get those photos. We just got to make a couple phone calls. I'm sure Bernie probably has a better route to that than.
Yeah, send me a shout out and just ask me what photos you're looking for, and I'll dig them up somewhere.
I'm good.
Thank you all for attending. We appreciate it.